So yesterday, I don't know if you remember this, but we determined that we could take the fifth root of 8 to the fifth, because the root and the power would do what to each other? Cancel out. They would just free up an 8. So the way you turn an 8 to the first into an 8 to the fifth is to multiply by the 8 to the fourth. And if you do it at the bottom of the fraction, you got to do it at the top. The top also gets multiplied by the fifth root of 8 to the fifth. Now, you're going to have to figure out what 7 times 8 to the fourth is. You just have to figure it out. Okay? I'm not saying do it by hand. 7 times 8 to the fourth power. 28,672. That's the guy that's stuck in the radical. Whether you like it or not, there's a pretty good chance that'll simplify. Well, if it's a 5-digit number, it'll probably simplify. You can probably reduce it. Now, I'm talking here about fifth roots. What I want is a factor of that number that I can take a fifth root of. If you understand how to simplify square roots, you should have a rough idea how to simplify fifth roots. So 1 to the fifth is 1. 2 to the fifth is 32. 3 to the fifth is getting pretty big. 243 maybe? Yeah, 243. No, I just done this a lot. 4 to the fifth is 1,024. Let's stop right there. Why don't you see if 1,024 is a factor of 28,672? But the idea is there. If I don't know these, I go to my calculator and I push things like 2 to the fifth and 3 to the fifth and 4 to the fifth to see if those are factors, right? That's the idea. How many times 1,024 into that thing? 28. 28 times. Fifth root, 28 times 1,024. What is the fifth root of that 1,024? What created it in the first place? Come on, what's the fifth root of 1,024? 4. 4 to the fifth made it, right? So 4 fifth roots of 28, sitting pretty over an 8. Don't stop there. You know, all that beautiful work, you don't stop there. Fifth root 28 over 2 is 4 over 8. Somebody should probably be teaching now, showing the calculators is, I can't do any of this. You know, you're a kid, I can't do any of that. It's a test, it's multiple choice, you have a calculator. It's a test and it's multiple choice and you have a calculator, you shouldn't miss it. You shouldn't. So I'm going to clear that. I need to write down what the final answer was, though. The final answer was fifth root of 28 over 2, before I forget it. Rewrite fifth root of 7 is the next one. We did this yesterday. We did it the day before.
7 to 8.
7 to the 1/5. Rewrite fifth root of 8. As soon as you can rewrite, you enable the ability to push buttons. You get that? As soon as you rewrite, you enable the ability to push some buttons. 7 rooftop 1 over 5. Go down, divided by, you can use the fraction key if you want. 8 rooftop 1 over 5. Enter. That little ugly looking decimal there, 0.97. If my answer is right, it's the perfect simplified form. Shouldn't I get the same thing? Okay, so you do have to know how to do a little bit of rewriting. And again, some of y'all not pushing buttons. I swear just pushing the buttons will help you remember the rule. But you're not doing it. Rewrite fifth root 28. 28 to the 1/5. Sitting pretty over 2. Let's see what that is. Don't you think you can divide it by 2, because you can't. Same thing. Multiple choice test, you got a TI-84 in front of you, you don't know how to do the math, or how to push the buttons. It's pre-responsibility, you're just SOL. Right? So learn math too. Definitely know how to game a multiple choice test. All right. You're taking ACT on too.
Yeah, I know. That sucks.
It's gonna be like that scratch card.
But it's, can we take it off?
No. Not unless you pay for it yourself.
How much is it?
I don't have to look off from the start and just set you up at testing centers. Well, I tell you, it was like $50, but you can have one. A sparkling that goes high end.
Yeah, can we hear it if you know what
I'm
it
taking
is?
reaching out or somewhere else. All right, moving on to C. We're not going to do D, we're going to do C. 7th root of x to the 5th over the 7th root of x to the 13th. What's something you could take the 7th root of when we're talking about powers of x? Come on, guys, you got to learn to think a couple steps ahead. It doesn't actually apply to this problem, but what's the 7th root of x to the 7th? It's x. Roots and the powers cancel. I want to be bigger than 13. I can't make something smaller. I can make it bigger through multiplication. Unless I use a negative exponent, so it doesn't work out. 7th root of x to the 14th. Exactly what it is. If you take x squared and you lay it out 7 times, x squared times x squared effectively, 7 times, what do you generate? That's how radicals work. Sometimes in mathematics, especially as you move farther up the ladder, you have to learn the ability to have a desired outcome. The desired outcome here is to make the bottom x squared. And you can achieve that outcome if you can turn the denominator into the 7th root of x to the 14th. Because the 7th root of x to the 14th, according to Marlowe, who is correct, is x squared. Now, I always forget to mention this because I just assume you remember. Why was there a problem with this thing anyways? A radical where in the denominator. And I didn't make that rule. I ruled 600 years in. Okay? So don't even pay much attention to the 7th root now. What do you multiply x to the 13th by to become x to the 14th? X. Well, it says x, so you all see that because we're supposed to add exponents when we multiply. You multiply the bottom by the 7th root of x, what do you multiply the top by? By the way, that thing has an understood 1, which I hate putting in there. So I'm going to put it in yellow so maybe you won't see it. Top. Bottom is done, by the way. We're done with it. We're not done with the top. Top is the 7th root of x to the 5th times the 7th root of x to the 1st. What's it become? 7th root of x to the 6th. I'm just going to beeline that straight to the end. But you can't do anything else with that. Is there a 7th root of x to the 6th? There's not. There's nothing you can multiply x to the 6th. You can't do it. You can't do x times x. You only can do x 6 times. It's not going to happen 7 times. So that's that one. And we're going to skip D. D is probably beyond the scope of this class. So we're going to skip it. Adding and subtracting like radicals and roots, and these will bother some of y'all because you look at this stuff and it just looks scary. It's just different. This is like doing 5x minus 3x is what it is. It looks funny, but you have a single 4 through 10 plus 7 4 through 10s. Are those like? Aston says they're like. So what is a singular 4 through 10 plus 7 4 through 10?
8
It's 8 4 through 10. I know it looks funny, and I get that, but those are like terms. And I challenge you to come up with a 4 through 10. If you can. I'll not push your buttons. I'll read 2 a little bit different. I'm going to read 2 as 2 5th roots 8. Why am I reading it 2 5th roots 8? Look at the exponent. It's 1 over 5. Isn't that the 5th root? Plus 10 5th roots of 8. Are those like terms? How many 5th roots of 8 do you have? 12 of them. You have 12 times 8 to the 1/5 power. And you shouldn't be surprised if somebody does something unusual here. You might actually see them key this out as what I was saying, 12 5th roots of 8. Because all they're doing there is checking to see if you understand how to convert from exponential notation to radical notation.
You just leave it like that?
I'm just saying, I don't make your test. A lot of times when they design a test question, they're actually testing 2 or 3 different things at once. They're testing your ability there to add like terms, and they're also testing your ability to convert from exponent to a radical. It's just, you've got to test multiple things at once. There's like 300 freaking standards in Algebra 2. You can't test them all with 55 questions, unless each question tests multiple things at once. All right, C, do they look alike? Oh, that's where your brain comes into play. Make them look alike. Cubic root of 54. Give me a number you can take the cubic root of that is a factor of 54. Eight, sadly, is not a factor of 54. Is it? 27 is. There's no cubic root of 9, buddy. There's not. You guys aren't memorizing your cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. A lot of you guys are on your form quizzes. You're just figuring out what they are. You're not memorizing, so it's not there where it needs to be. So when I look at the cubic root of 54, I see the cubic root of 27 times 3. Try that, 3. Look at 3, what would it be? 2. And then take away another cubic root of 2. Suddenly these things are about to become like terms. Because what is the cubic root of that 27? 3, because a 3 cubed made it. Now we're looking at 3 cubic roots of 2. Take away a single cubic root of 2. These are like terms, right? So how many cubic roots of 2? 2 of them. How many kids can do that? About 1 in 10. That's what it sits at. It's about 1 in 10. Do you have a TI-84 in your in front of you? Do. Rewrite the original expression. What's cubic root of 54 look like with exponents? 4 to 1/3. And write it down. Some of y'all just stare at me. If I was a TV show, I would get canceled. It wouldn't be cancel culture, it's just boring. Nobody would watch it. All right? Don't just stare at me and think you're going to absorb it. This isn't osmosis. Do it. Take away 2 to what power? 1/3. I actually am quite certain I would get killed because of cancel culture. 54 rooftop 1 over 3. Which is funny because I'm actually a very accepting person. Take away 2 to 1/3. Funny looking decimal, right? If our work was right, we generate the same thing. On a multiple choice test, if I see that, hopefully I can convert it to an exponent form. So take that 2 cubic roots of 2 and tell me how it would look like as an exponent. It would look like 2 times 2 to the 1/3 power. Write it down. Don't kill me. You're 17 years old. It literally hurts me to move my hand, and I still write. What's your excuse? 2 times 2 rooftop 1 over 3. Ta-da! Same thing. There you go, kids. Multiple choice test, you're good. Free response? Maybe not. Huh? Yeah, I'm not ever going to show you where that's at. I don't want you using it. You need no exponent rules. Believe me, I know where everything is and everything. Simplify the expression. This is the cubic root of 64 y to the 6th. I got a little hint out there talking about dividing the power by the root. You ought to know what the cubic root of 64 is. You ought to know that. You should know that. So I'm just going to do that little piece. 4 cubic roots of y to the 6th. This is actually just an introductory problem. It's to teach you a little shortcut rule over here. When you talk about taking the cubic root of y to the 6th, ideally what you do is you think about it as the cubic root of y cubed times another cubic root of a y cubed. Because remember, you've got the break apart rule, so you can break a radical apart. You've also got your rules about exponents. You should know that y cubed times y cubed is what? Y to the 6th, because we add exponents and we multiply. So you break it apart and you look at it like that. What's the cubic root of a y cubed? Y. Cubic root of a y cubed is a y, so each of these generates a y. It turns out the cubic root of y to the 6th is y to what power? Y squared. That's how that thing simplifies. So notice here that the root was a 3 and the power was a 6. It says divide the power by the root. What's 6 over 3? 2. I'm going to add a little bit more to this. Not only do you divide the power by the root, remainders are left inside. Now we didn't have a remainder to worry about, so we're going to have to make some stuff up that does. So maybe somewhere on previous notes where you've got free space or something, or the very bottom of your notes, whatever, here's some new problems. We need to make some stuff up that has more to do with this theorem, this idea. These are the ones that I kind of have to figure out how to do. There's a way to cheat with calculator. I'm not ready to show you that level of cheating. It's just a lot more complex. You guys never know how to adjust a window. Not ready for that yet. So, somewhere, anywhere, you got fifth root 64, x to 12, y to the 4th is even 13. All right? The number we'll do separately. $32 and 2, that's right, Alex. He's right. He's right. 2 to the 5th is 32. I swear it is. If you were to push buttons on the calculator and play around with 5th powers, you get the 2 to the 5th is 32. And so what is the 5th root of 32? 2. So we got 2 5th roots of 2. That's how the number's going to simplify, okay? So we'll just leave that off the side until we're ready for it. But knowing how a number simplifies gets you pretty far. All right, so we want each of these individual pieces. How many times 512? Twice. I'm going to throw an x squared out front. How many times 5 enter 4? Usually once.
Something stupid like that, probably.
Nuts. Nuts.
Yeah, right.
So don't worry about what's out front on Y. How many times 5 and 13? Twice. Y to what power? So, oh, that's a Z. Thank you. That is uncorrected Army. I don't even know my letters. Z squared. All right, let's think about what else we have. There was a 2 from that guy out front, wasn't there? It's got to go out there. Fifth root. There's a 2 still on the interior. Now, we did 5 enters 12 twice. What was the remainder? 2. X to the second. 5 didn't enter Y at 4. Y to the fourth is still there. How many times 5 enter 13? What was the remainder? Remainder is 3. So here's actually a good little test skill for these. You can actually kind of cheat your way through things. The number, not so much. I guess you could. If you see a test question, you could take 2 and raise it to the 5th. What would it give you? And then multiply by 2. 64. Okay, that'll recreate the number. And this again is for multiple choice questions. You're looking at a choice. 2 to the 5th is 32 times 2 is 64. That creates the original number. 2 times 5. Add 2. 12. 2 times 5. Add 3. 13. See it? That's how you check your work real quick. And if it's multiple choice, that's how you answer the question. All right, let me make up something else for y'all. I kind of want you guys to spend a little bit of time. I'm going to drop the number, just focus on variables. Let's not do 5th root this time. Let's do 7th root. Seventh root. And I'll give you guys another, well, a minute or two, about 2 minutes. See if you can figure it out. And I really don't know an easier way to do this. I wish I did. Well, since Cadence is already deep into her phone, there you go. Cadence, what'd you come up with?
X, Y, Z to the third. The 7th root. And X, Y to the 5th.
I'm good with that. So for some of y'all, let's talk about checking our work. Because I know not everybody came up with that. I'm going to put some understood exponents in place. Okay? But not everybody sees those, even though they're understood. And let's talk about that multiplying and adding thing as we check the work. All right? 1 times 7, add the 1. 8. Perfect. 1 times 7, add the 5. 12. 3 times 7, already counted for. Use a little check rule, kids. I hope that you see. Does everybody understand the little check rule there? Do you at least appreciate what that will do for you on a multiple choice test if you can remember it? It takes something like that, which for a lot of kids is a 3 or 4 minute problem, and makes it just a couple of seconds long. All right, done with those. All right, on to B. Hope you didn't write all over it. Some jerk of a teacher at some point in your life asked you to remember a rule that talks about A times B to the X. What's that look like? It is A raised to the X times B raised to the X. Now that thing has three things in it, but it's the same rule. If it works for A times B, it works for A times B times C. Does that make any sense? It's the same rule. It's not a rule about addition or subtraction, it's a rule about multiplication. It's essentially saying you can distribute exponents. Oh, it's saying, and it's not technically a distributive property, but it's allowing you to move that exponent to each individual term. You have a 27 to the third power. About 3 times 30? 20. 12 times 30? 4. If somebody's giving you things that are an exponent, you could rewrite it as a radical if you wanted to, but there's absolutely no need to. You can just distribute the exponent and be done with it. It's way quicker. Don't you dare leave an answer like that. 27 to the 1/3 power. Hardly what root is it asking you to take? The third root, right? What is the third root of 27? 3. There's your answer. 3p q to the fourth. You'll never see a standardized test have p to the first written on it. It's understood. Moving on with our lives. On to C. C is what we just did on those previous examples. Just got a fraction in. Yay, friggin' what? I'm curious right now about the fourth root of m to the fourth. Just m. All it is. Just an m. And it's up top, stays up top. What happens up top stays up top. Now I'm curious about the fourth root of m to the eighth. And squared, because how many times is 4 enter 8? Twice. Here's a good question. Real good question, we're in a course test. I think it is.
So you can square at the bottom.
Is it a radical? The only issue is radicals. Nothing wrong with having squares or cubes or anything. The only issue is radicals. That stems from how they used to do math, which is not something that you could comprehend. This stems from how math used to be done prior to technology. And there's no way to comprehend that because we've grown up with technology. So I foresee within 20 years that we'll quit doing an issue. Probably won't have teaching anymore. Because technology's pretty better right now. All right, we got 14xy to the third over 2x to the 3/4 is e to the -6. What's the easy part to do? What you got there? One question I get all day long. Go ahead. 7, isn't it? Never get us how I do something, how we do something. So I go for you. All right, to do this problem, again, you have to know another rule. You have to know the rule about x to the a over x to the b. It is x to the a minus b. Or 1 over x to the b minus a. One of the two. If they're the same, it's just one. But it's one of those two. So as we focus on the individual pieces, the individual variables, we'll decide which one to apply. So if I put my attention on x over x to the 3/4, and I remember the understood 1, am I going to do a minus b or b minus a? What's bigger? 1 and 3/4. That's what you're going to subtract from, isn't it? Because remember the idea here is no negative exponents. Remember that idea? That's the idea, no negative exponents. What is 1 minus 3/4? 1/4. Subtraction was done up high, the result is left up high. I don't see any y's. Do you worry about other than what's up there? That guy's fine. Anything wrong with z? What's wrong with it? What are you doing? Move it top. Unit 6. Remember, this is a section that deals with exponents, kids. It's all we're learning today. Manipulating exponents. I know exactly how much fun it is. I love this crap. You probably don't. We're going to skip A because we've already done something like it recently. You probably already forgot, so be it. Move on to B. You already forgot, didn't you?
No.
Oh, okay. I moved too fast. You're not saying so. Kids used to tell me that I talk too fast.
Well, I had it, but I.
I don't talk too fast. You listen too slowly.
Oh.
And I'm a hybrid. I got Yankee blood running through me, but I was born and raised here in Tennessee. So maybe I do talk a little too fast. Also full German. I spoke in my family all the way up to about 2 years past World War II, and then they just quit saying it. No, my family quit speaking it in 1944. My dad knows it. But they quit speaking it. Why would they quit speaking German in 1944? Nazis are bad. It does bug me though that they quit speaking it. You know, in a lot of Hispanic households, most of the Hispanic kids you see are bilingual. Because what do they speak at home? Yeah, what do they speak in real world? I wish I would have learned German because then I would know a second language. And I could say all those amazing German curse words, which are just horrible sounding. And you guys wouldn't have a clue what I was saying. It would be great. Everything in German just sounds mean. But it really bugs me that, you know, they quit speaking German. I personally would take this thing and I'd break it into 2 pieces. If I don't do it on paper, I better do it in my head. Okay? Somewhere along your thought process on B, you're breaking into 2 pieces. What's wrong with it? Got a rabbit in the bottom. So there's been 2 examples so far I've done with you yesterday and today where the goal has been to reach a desired outcome. This is one of those 2. You can't take the 3rd root of y to the 8th and get a nice whole thing, but you can multiply it by something. What's something a little bit bigger than y to the 8th that you can take the cube root of? It has to be a little bigger than y to the 8th. Because I'm still going to have radical in the bottom. I cannot have a radical in the bottom. That is the rule. You cannot take the cubic root of y to the 8th, but if you just made it a little bit bigger, you could. What's the power of y that's bigger than 8 that you can take the cubic root of? You should all punch yourself in the face when I tell you the answer, so please don't get to that point. What is something a little bit bigger than y to the 8th that you can take the cubic root of? You could take the cubic root of 27, but that's a lot bigger. Right? You can't take the cubic root of 8 of y to the 8th. You can take the cubic root of 8, but I'm not talking about
9.
9. You can take the cubic root of y to the 9th. You can, I swear. Looking on a piece of paper. What's the cubic root of y to the 9th? Not y squared. That's your desired outcome. I want to multiply that by something so that I become the cubic root of y to the 9th, which I know is y cubed. What do I multiply the cubic root of y to the 8th by to become just the cubic root of y? Don't worry so much about the cubic root sign as what's on the interior of that thought process. Y to the 8th times y is right enough. I hope that's starting to click with some of the desired outcomes here. And it is hard for a lot of kids to do. But if I do it to the bottom, I gotta do it at the top. A lot of math becomes later on as you take it, not about following rules. You're supposed to know all the rules by then, about trying to figure out how to get to a desired outcome. What is the cubic root of x times the cubic root of y? Cubic root of xy. That comes from knowing how to simplify radicals and stuff like that. Just putting things back together. So there's your answer. Cubic root of xy over y cubed. Why would you do something like that? Well, so that when you get to calculus, you can take the derivative a whole heck of a lot quicker. But how many of you guys are going to take calculus? I don't know. Not that many. More adding and subtracting. We're not going to do A because A is just simple like terms. Hopefully you agree the answer is negative 5x 4th roots of y. If you don't, so be it. We're going to do B. Because those don't look like terms. It's just more radical simplification. 2z to the 5th, not like 54z squared. So let's clean this thing up first. That cubic root of 2z to the 5th. That's that whole how many times you enter. What's the remainder do? Times 305. Once. That lets me put a z out front. Cubic root 2, still there. Didn't touch it. What was the remainder? Give it a second. It's closer now, isn't it? We both have z squared. So let's just pay attention to that cubic root 54. Heck, we've done that once in our notes already. You can just go back and look if you remember us doing it. 3 cubic roots of what? It's 27 times 2, kids. What's the cubic root of 27? 3 cubic roots of 2. This becomes 3 cubic roots of 2. All right, so minus, I've got to introduce that 3 that was pulled. There's a z, cubic roots, 2, and it already contained the z squared. And as funky as that looks, are they now like terms? That's the deal, they're now like terms. What's 12z take away 3z? 9z. So 9z cubic roots of 2z squared. And again, this is one of those things that maybe 10% of student body can do. It's not something that has a high level, still a high level of success. So here's what the other 90% of you students can do if it's multiple choice. And that's a big deal, if it's multiple choice. You can rewrite each term with exponents. And then you can push buttons. And you should probably take notes on this because a lot of you guys are not going to know how to do it. 12 is obviously going to be there. How about this cubic root of 2z to the 5th? As smart as you are, that's wrong. 2 to the 1/3. Z to the 5/3. Because the 2 did not have a 5 as an exponent. Did it? You should probably write that down. This 2 had an understood exponent of 1. It helps at your age whenever you don't see an exponent to put it there. Because you just haven't done a lot of this yet, have you? It helps at your age whenever you don't see an understood exponent to put it there. Take away z times what? 4 to the 1/3. Z to the 2/3. That's the original expression. Now, when you take a standardized test, graders of tests are very familiar with the storage feature or the ability to make up a number and plug it in. You're not supposed to plug in zeros, ones, or twos ever. I highly suggest that you plug in something random like pi. And not 3.14, the legit pi symbol on your calculator. If you're trying to game a standardized test, use weird things, irrational numbers like √2s or √3s or pi's. Okay? So play along with me. I'm going to take a pi, which is second rooftop. I'm going to store where? So it does. And then I'm going to type in that thing we wrote, right? 12 times 2 to the 1/3. We don't have a Z key that we use. We stored it in X, so Z becomes X on the keypad. And again, you need to be pushing the buttons. Milbrath is showing you how to cheat, and some of you just not doing it. One-third, 2/3. Seems kind of funny to type X54, but I think it works. 54 is an exponent too. Once you press enter, you're going to get a weird looking decimal. I mean, you threw pi at it. But just kind of remember what that decimal is. Now, you're still going to have to retype your answer choice thing. So you're still going to have to do your conversion, okay? So we need to rewrite 9z cubic roots of 2z squared. I actually don't mind showing you how to do this because you're learning exponent rules, aren't you? Are you not learning exponent rules? You are, right? You got your 9z, nothing to do with that because it's not even radical. Rewrite cubic root of 2z squared. 2 to the 1/3. If you're writing and pushing buttons like you shouldn't have a problem with this conversion very well. You should not. So if everything is done right, this is going to generate that same decimal. Next, I use parentheses there, 2 rooftop 1/3. And then we got x to the 2/3. There we go. I think we just finished on those anyway, so good timing. It's the same too. Enjoy your day.
Okay.
Hold on before you start complaining. Let me stop recording.